general objective is to build the pendulums that we have shown in a video in class, and with the result of the time and the length of each pendulum, we will create a worksheet or a computer program to provide about information frequency, angular frequency, position, and damping period. For the settings, we're going to use 10 pendulums, and each pendulum is going to have a different length. The largest one is going to be of 40 centimeters, and the shorter is going to be 22 centimeters. The theory and data of pendulum wave, we're going to use only this formula, and to get the B that is missing, we are going to isolate B from this formula, and in this moment we don't care about this component, so the resultant is going to be this one. But and then we need to find W to this part of the formula. So W it's equal to all of this, the square root, and K that we don't have, well, that we don't know, it's equal to the mass times gravity divided by the length of the pendulum. Okay, so here we have all the data that we have already, and here we have the data that we have already collected from all the pendulums. So we can see here that we have the length of each pendulum. This is the higher length, and this is the minimum. And then this is the weight of each one of the pendulum. This is the final time of each pendulum. We only use 10 of them. The amplitude of each one. Here we have the final damping. For this final damping, you need to use a logarithmic function. So you can't put zero in there. So you need to put 0.0001 or one number just right behind 0. And here we have the period, where also, as I explained in the theory and data, you can get it from the formula of 2 pi square root of length divided by gravity. The W, you can get it for a formula that it means, well, in the formula it's the damping, the mass, the constant of each pendulum, and that's all. And the frequency that as you know is the inverse of the period. So now here are all the graphs of each pendulum. This is the first one. This is the largest pendulum, and for this formula, you just need to know that
the only angle, well, that 20 degrees is the maximum angle that you can use in this formula. So you need to remember that. And if you can see here, you can see the damping, how damping is going in this pendulum. So here the amplitude is bigger than the other because the pendulum, well, the length of the pendulum depends on the amplitude. And as you can see here, the green one is our second pendulum. Both of them goes closer to the x-axis, so that means that every pendulum needs in one certain moment it's going to be zero their amplitude, and this happens with all of the other pendulums, just to show you how it will going to be the movement, the oscillatory movement of it.
Okay, the recommendation that we give it to you is to use more pendulums and to make sure your pendulums are in equilibrium because you're working with gravity. In conclusion, all the data that Momos gave us works as the theory said.